circle of a vision from the perspective of a fish. Okay, so what happens, suppose there is a medium, boundary that separates two medium. When light travel from this medium 1 to second medium 2, so when it travels from this medium and for a particular angle, this is a normal, okay, this is a incident ray, this is a normal. For a particular angle, the light ray bends 90 degree. That means the refracted angle is 90 degree, and that angle is critical angle. Suppose the second medium is air, the first medium is any medium whose refractive index mu. Then according to Snell's law, mu1 sin theta 1 equal to mu2 sin theta 2. Mu1 is this medium, mu2 is this medium. This medium's refractive index is mu. Theta 1 is this angle, incident angle, which is critical angle, sine of critical angle. Mu2, this medium, since it is air, its refractive index 1, and sine of angle, this angle is 90 degree because that is a critical angle. Only then light graces the boundary. So mu sine C equal to 1, which implies sine of critical angle is equal to 1 by mu. So we know sine theta is opposite side by hypotenuse side. Suppose let us assume a right triangle with the angle critical angle. Sine C is opposite side by hypotenuse side. Opposite side is 1, hypotenuse side is mu. Then this adjacent side will be equal to this square minus this square. So mu square minus 1. Suppose if you assume a right triangle whose one of the angle C, then the sides are in this ratio 1 mu and root over mu square minus 1. Okay, so what happens to a fish? How it sees outside? Let's see. Suppose this is the pond boundary, and when the fish is here, when the light travels, it critical angle, it graces the boundary. In all direction, when light travels here, it graces the boundary. When light travels here, graces the boundary. When light travels here, graces the boundary. So all will form a circle. So that means, suppose if sun rises here, for the fish it will travel along the boundary and reaches the fish over here. When sun sets here, the light travel along this boundary, reaches the fish here. If anyone is just trying to coming out of the water surface, it will travel along this line, it reaches the fish. So basically how fish will see is like this. If the fish is here, if the light comes from the sunrise, reaches the fish here, means the fish eyes will project the sunrise here. If the sun sets here, it will reach the fish through critical angle, means from this direction it will project. So the fish sees the outside world in a circular window. So now we are attempting to find the radius of the circular window. So this is what the radius, right? This is the center, this is the radius r. So here it is the same thing. Let's draw this line. Here is our fish, and this is the critical angle, and this is the boundary. So right from the center of the surface, this is the depth h at which the fish lives. This is the critical angle, the light leaves here. So this point is O, this point is P. So this O to P, this distance is called radius. This is where the point O, this is where the point P, this is OP. This is R. This is the radius of the circular window through which the fish sees the outside. This is R. So if this angle is C, this angle is C. So what is the opposite side, adjacent side for this tan angle? So what is tan of critical angle? Opposite side by adjacent side. Opposite side is radius by adjacent side is h. But if C is there, sin C is 1 by mu, means tan C. Tan of critical angle is opposite side by adjacent side. 1 divided by root of mu square minus 1. Substituting this up here, in place of tan C, it is 1 divided by root of mu square minus 1 equal to r by h. Then which means that the radius of the circular window, or we call it radius of the circle of vision, equal to, cross multiply this here, r is equal to h divided by root of mu square minus 1. This is the radius of the circular vision through which fish sees the outside world. This problem can be asked in very many different ways. Suppose there is a cube. Inside the cube, at the center of the cube, a light source is kept. What area is to be covered here so that the light rays will not escape? Because this is a denser medium. When light comes at the critical angle, it will come, it will hit, it will go out. So the light will go through a circular window based on the above discussion. So this is the circular window through which light sees out. Suppose they ask what is the area to be painted so that light does not escape from one of the faces. Means suppose if this is the cube of side A and this object, let us say at the middle, means it is A by 2. Based on this formula, this radius of the circular window or circle of vision r is equal to h divided by root of mu square minus 1. Here h is the source is at the center of the cube, means if the cube side is A, the source is at A by 2. So it is A by 2 divided by root of mu square minus 1, or A by 2 root of mu square minus 1. This is the radius. But we are supposed to find the area to be covered. So this is a circular area. So area to be covered equal to pi r square. That means pi into r value is a square. So it is a square divided by, we'll first write a by 2 root of mu square minus 1 whole square. Hence, this is the area to be covered in one of the faces. So for a cube, there are 6 faces. For the total area to be covered on the cube so that no light comes out, so it is total area will be equal to 6 times that of the original one of the side area. 6 times pi a square divided by 4 into mu square minus 1. This is the area to be covered.